Everyone, welcome to Notes 3.06. If you haven't already, please go watch the other YouTube video that's posted in today's classroom. It really has good animations to explain these methods of proving one triangle congruent to the other triangle, okay? If you need to rewatch it 2 times, again, it's only a 7-minute video, and I hope to go quickly through this here. But we have 5 methods of congruence. We have side congruence, side, angle, side, angle, angle, side, which are a little bit different. And then we have hypotenuse, leg, which is really angle, side, but we rename it. And what that means is we have 3 corresponding sides of one triangle marked equal and congruent to 3 corresponding sides of another. This single dash, triple, double would line up. When you have all 3 sides marked, you're going to end a proof with side congruence. And I'm going to show you a couple proofs today. Side, angle, side means you have 2 sides and the angle included between them. So again, if I do a little highlighting here, okay, you have one side, a second side, and where those 2 angles meet is an angle that is congruent to 2 corresponding sides, side, and angle between them. Angle, side, angle, and angle, side, or side, angle, it really depends on how you look around the shape. Angle, side, or around the other direction, side, angle, are different. They both have 2 markings on your diagrams for 2 angles and a side marking, but one side is between the 2 angles, the other side is outside of the 2 angles, okay? So if you have angle, side, angle, you have an angle marking, the side shared between those 2 angles that they share. Angle, side is this next diagram, okay? So again, these diagrams come in pairs. So these 2 would be congruent to each other. Now these 2 we're looking at, okay, is an angle marking, another angle marking, but we don't have a marking between those marked as congruent or given to us in that set of rules, okay? So remember, in the given information for a particular problem, you have some information that tells you what is congruent. We don't know right now at this point that side's congruent. So the side is over here. So this is considered angle, side, or if we look around our shape in the opposite direction, side, angle. Okay. Hypotenuse, leg is really the case for an angle, side, but we don't like to say ask in math class. So instead, it's renamed hypotenuse, leg. So this, again, HL is for right triangles only, so you do need a 90-degree angle. And if I knew this side's measure, let's say 3, and this double dash over here would be 3, and the hypotenuse measure was 5, and this hypotenuse measure was 5, I could use Pythagorean theorem, since it's a right triangle, to find the third set of sides. So knowing that it's a right triangle and you have 2 sides measure, you could technically be using Pythagoras to find the third set of sides, and they're going to be equal to make those 2 triangles congruent to another. Assumptions. So again, we're going to be given a set of rules. So last class, this classwork we went over the other day, okay? These little bits of information are now all going to be put together into longer proofs, okay? But an assumption, something you can assume is your reflexive property. So on that picture, you don't have this already marked. I'd like you to put it here as a big X. These 2 triangles meet on this side BC, where the length of BC in the first triangle and its length in the other triangle would be equal. So we could say that BC is congruent to BC, and the reason would say reflexive property. So if we think of that as parts of that 2-column proof. Something else, we could have a reflexive angle. There's technically 2 triangles in this picture. Triangle BFH and triangle BRM. Okay, and those 2 triangles overlap at that angle B. So we could use the reflexive property there to say angle B in the first triangle is congruent to itself, angle B, again, using that reflexive property. Vertical angles, again, if you put this 1 and 2 in a picture, if you have that butterfly or bow tie diagram, we could always say that angle 1 is congruent to angle 2 by vertical angles are congruent. And again, that's from our boxes on 3.05. Okay, so those are some assumptions. We're going to come back to the bottom of this page a little bit later, but this is like your cheat sheet to kind of give you some diagrams and what the theorems are from the video you just watched. So moving ahead, we're going to start a proof. And these are the steps to writing a proof. So we're going to kind of take it slow today. You're not going to have to write a proof by the end of your notes or your classwork today. But what you do have to do is take these rules, this given information. Step 1 says to mark up the picture. So mark the diagram with the given information, meaning if these angles are congruent, we're going to put arc marks in there. So they're not going to have those little markings on the diagrams for you. So again, these pictures is what our goal is. We're trying to get sides, angles, and sides, or angles, sides, and angles. That helps us decide the method of how to fill in the rest of the proof. Okay? So taking this information, angles A and C are congruent. What I'm going to go over to my picture and do is put a little arc mark in at A and an arc mark in at C. So when you have this given information, you need to mark up the pictures. The next piece, angle 1 is congruent to angle 2. That's given. That's part of their rules for this problem. So we're going to put a double arc in at 1 and a double arc in at 2. So I'm color coding. You can be bringing highlighters to your state exam to help yourself if you want. Or you can just do it in one color if you don't have highlighters. That's fine. B is the midpoint of AC. So since B is the middle point on AC, B is the midpoint of AC, that gives us that this segment AB and BC are congruent to each other by definition of midpoint. So now that we took those bits of information and we marked them into the picture, what we're going to do is now we need to go to step 2. So I took the given information and any assumptions. So again, the 2 assumptions we have are reflexive property or vertical angles. Okay? This diagram doesn't have either of those. They gave us the fact that angles 1 and 2 were equal here. So these technically actually aren't vertical angles because this is a horizontal line and this kind of is a V here. But now we have to decide, is this a side, side, side case, side, angle, angle, or angle, angle, side? Now the last option, HL, I know it's not that because it's not right triangles. So since we don't have any right angles, we can't use hypotenuse leg. So we're trying to decide what is our method of congruence here. Well, I have 2 sets of angles marked, right? Angles A and C, angles 1 and 2. And this midpoint gave me a set of sides. So this diagram, I usually cover up one triangle. I focus on one triangle at a time because these markings match up to the markings over here. This triangle would be reflected over in order to lay on top of that BEC. So cover up one triangle, only look at one at a time. That's the marking for an angle, a side, and an angle. So this triangle is congruent to this triangle by angle, side, angle. So how that formats into the proof. So again, this given information is asking us to prove at our conclusion that this triangle ABD and this triangle CBE are congruent to one another. So all of this information was our given. We have a set of angles. We have the other set of angles marked as congruent. That's like our little checklist. So this ASA means we need 3 congruence statements in our proof before we can get to our conclusion. So angle A is congruent to angle C, angle 1 is congruent to angle 2. Then, since we had a midpoint, we need to say what set of parts were congruent. So these two lines here are really what we were doing on classwork 305. So AB is congruent to CB by definition of midpoint. So now that I have three sets of parts, again, we need a set of angles, the first A set of sides, the AB and CB, and a set of other angles, 1 and 2, is our angle side angle, orange, pink, green. Is orange, pink, and green as congruent statements here? It is. They're not necessarily in order. That's okay. All right. So it's not listed angles, sides, angles, but we have two angles in the sides. Based on the markings in the picture, triangle ABD is congruent to triangle CBD by angle, side, angle, congruence is where this acronym goes. So that's a new set of reasons. Okay. So again, these are the methods of proving triangles congruent. So they're methods of proving triangles congruent, meaning it's an outline. You need two sets of angles and a set of sides listed as congruent to make these two triangles congruent. Then we conclude our proof by saying angle, side, angle. And again, that's a shortcut to say this whole statement here. So what ASA stands for is if two angles in the included side of one triangle are congruent to two corresponding angles in the included side of another, then the triangles are congruent. So this acronym ASA, congruence, stands for that long sentence right there. So it's our little shortcut. Exercise 2. Okay. So that was a whole proof. That's what a triangle proof is going to look like. So we're going to be doing these probably more toward the beginning end of next week. Today, we're going to focus on taking the given information, marking the picture, and deciding which method of congruence we need. So looking at number 2. Here they give us that we have two lines, AEB and CED. AEB and CED are two lines, meaning they intersect at point E. So this is actually a little clue to tell you you have some vertical angles. Okay? So those vertical angles we can assume is congruent. So I'm going to put the little bow tie in at E on either side. And when I put the bow tie in, I need to put a little 1 and a little 2. That's my shortcut. You're going to see it written out a little bit differently here. Next, we have a bisector. CD bisects AB. So again, this, remember, is a segment bisector. So what a segment bisector does is creates you equal segments. So AB is cut into two equal pieces. Now there's another line. The other rule of this game here, this proof, is that AB bisects CD. So again, we're bisecting segment CD, gives you more segments. Okay. So how we're going to go about this, and again, this is where you should be pausing your video, making sure you're marking as I am. If you don't have highlighters, single dashes went here, double dashes went there, a 1 and a 2 went here. Okay, marking that angle 1 there and angle 2 here were equal. So again, that there, those vertical angles are assumed to be congruent. You don't need any information here to tell you that. This was just a little clue for us that you have two intersecting lines creating those vertical angles. Okay? So if we have a segment bisector, we created equal segments. Another AB bisects CD is another segment bisector. So this is a segment is a set of sides. Vertical angles is a set of angles. So we have two sets of sides marked. These sides, 1 and 2, these sides. So to decide the method of congruence, do I have sides, sides, and sides? Do I have 3 side markings on all 3 sides of my triangle? We don't. Do we have side, angle, side, angle, side, angle, 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 side? So again, I like to list out my methods. These are the 5 options. Side, 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 angle, side, angle, side, angle, 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 side, HL. Okay. We don't have all three sides, so that can't be my method of congruence here. I don't have any facts to tell me AC and BD are equal. Okay. Side angle side. Well, if I cover up one picture, it's a lot easier to see this. Do I have two sides marked and the angle where they meet? I do. So this is going to be side angle side congruence. And the reason we need to decide that is it becomes our last reason in these proofs. Now to kind of backfill everything else we need, that's our conclusion. Our given information helped us mark up the picture. From those markings in the picture with this data, okay, these facts, we decided that we have the markings for sides, angles, sides. Now we need to go in and fill in the body of the proof. So what they have here for us is with these segment bisectors, since CD bisects AB, didn't we have AE congruent to EB? So we needed to state that as a fact in our proof. And since we have marked CE and ED by the other bisector, now we've marked CE and DE congruent. Okay. And the last bit of information were these vertical angles. Now they used the three-letter combination AEC and BED for angles 1 and 2. Typically, I would write instead of that, I would have said angle 1 congruent to angle 2 because I like that little shortcut. Okay. But what are those reasons? So why were these segments congruent? Well, we were given a bisector. So this is by definition of bisector. And how come these angles were congruent? They were vertical angles. So our reason here is going to say vertical angles are congruent. So again, to have a full and complete proof, okay, you need to have, if your method of congruence is by side, angle, side, you need to have two sets of sides listed as congruent within your proof and a set of angles. Okay. Now I could have reorganized this. I'm going to show you some of those options as you're putting these proofs together. What makes sense for some of you is going to be a little bit different than others, but we're going to do more of these proofs next week. Okay. But again, what we're going to focus on today is this first piece. It's taking this given information, marking up the picture, and then deciding which method of congruence we have. So looking at our classwork page, our next page here, kind of have to turn sideways. The directions are very specific, and we're going to follow them to the T. Mark the diagrams. What I mean by that, if you have a side, you're going to put a dash mark on it. If you have an angle, you're going to put an arc mark in it. So that's what I mean by mark the pictures. And determine what method. So side, 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 side angle, 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 side, HL, and none are your options. Okay? None would mean we have not enough information. INFO, mislock. Okay? If we have not enough information, it's going to be none. Or if we have two sets of parts, but not a third. So with exercise 1, we're going to take these 3 congruent sets of pieces and go and mark them in our picture. So if AC is congruent to DF, now I'm going to do this without highlighters. If you want to keep with the highlighter options I was showing you in the first view, that's fine. But AC is congruent to DF. This one's congruent to this one. Awesome. And then angle A is congruent to angle D. So we're going to put an arc in at A and an arc in at D. Angle B is congruent to angle E. B is here, E is here. So I know I have 2 sets of angles and a set of sides. So some options we're eliminating. It's not going to be side, side, side. It's not going to be side, angle, side, because I only have one side marked in each triangle. Is it angle, side, angle, 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 side, or HL? Well, it's not going to be HL because there's no right angle. So now we're between these two. And we did do this if you have the Wednesday activity this week. Angle, side, angle is when you have 2 angles and the side between them. Here we have these 2 angles, but we do not have side AB marked. So it's not going to be angle, side, angle. The best answer here is angle, angle, then a side. So how I usually decide, looking around my picture, is I start at a marking. This is the marking for a side. Okay. Then I go clockwise or counterclockwise around my picture. The next marking is for an angle. That's an angle marking. Then I go around to the next marking I have, and that's another angle marking. So I have side, angle, angle, which is just angle, angle, side, backwards. So this and this are the same thing. Next picture. We're going to move down to number 3 here. Okay. First off, ding-a-ling-a-ling, this picture reminds me of my notes a second ago. It's the same as this picture here. An assumption we're going to make when we have two triangles kind of flipped over, reflected over a side. This is our reflexive property. So I'm going to go right into my picture and I'm going to put a big X on AC. I know that AC in that triangle to the left and AC in that triangle to the right is going to be equal. So that's already a set of sides. Okay. Now they also give me that AB is congruent to AD. So A to B, we're going to use a single dash there, and AD are equal. And also BC and CD are equal. So here are the markings for one set of sides, the other set of sides, and by reflexive property, we do have the third set of sides there. So since no angles are marked, it can't be any of the options that have angles. Now HL technically would need a right triangle, so it's not going to be that one. So the best choice here is side, side, side. And again, we needed the reflexive assumption here in order to find all three sets of sides. 3 and 4. If you want to pause the video and try these on your own and then restart, you can. I'm going to mark up the picture with the given information. Angle A is congruent to angle C. Angle 1 is congruent to angle 2. And B is the midpoint of AC. So if that's in the middle, this gives me AB and BC as sides. So a midpoint always gives you a set of sides because it's a segment. So AB and BC are congruent. And again, we cover up one triangle. Okay, we start looking at our markings. Well, I have two sets of angles. So I'm going to eliminate side, 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 and side, angle, side. There's no right triangles. So now I'm between these options. Covering up one picture, there's an angle marking, a side marking, and an angle marking. So since the side is between the two angles, okay, so since we have the side between the two angles, it is going to be angle, side, angle. And this is actually one of the proofs we just did. This exact information is the start of the process where we finish out that proof over here, just to show you where these proofs are going. Number 4. Only information given is two sets of sides. Okay, AD is equal to BC, and I use double dashes on those. DE, and CE are equal. There's no other given information. Okay, so now we can think of any assumptions we have. Is the reflexive property where the triangles share a side or an angle? No, those are two separate triangles. And is there vertical angles there? Is there a bow tie figure where the two lines kind of come into angles? There isn't. This is going to be a none. These angles here at E are not technically vertical. This line is coming across, and these are kind of bouncing down and then back up as a V. That is not the same as an X. All right. It's almost like a W or an M shape there, not an X shape. All right. So the best answer here was none. We have a few more. Number 5. I see my bow tie. I'm automatically going to be drawing in my vertical angles. That's an assumption. So I'm going to assume those vertical angles. CD bisects AB. So we have a bisector there. And AB bisects CD. Again, another segment bisector here. This is actually the other proof we just did. So if I cover up one picture, I'm going to look to the markings. That's a side, angle, side. So it's going to be this choice here. Okay. Now at this point, I'm going to do number 7 with you and number 8, because those have, I guess, 7, 8, and 10. I'm going to skip 9 and 6 for timing today. But 7, 8, and 10, I'd like to take a look at, because those are some different information that we haven't seen yet in this class. In this notes page, I should say, today. We saw it in notes 305 last time. AD bisects angle BAC. This gives you a set of angles. So the angle at A is bisected into 2 equal pieces. I'm going to put a 3 and a 4 in there. This diagram gives you another set of angles. AD is perpendicular to BC. So remember, when we mark a picture, angle bisector gives you your arc marks here. A perpendicular gives you these little boxes here. So if those are angles 3 and 4, maybe I call these 1 and 2. So we have 2 sets of angles. So we're going to eliminate side, side, side. We're going to eliminate side, angle, side. Now we're looking at angle, angle, side, angle. And we still have HL as an option. Why do we have HL as an option? Because we have right triangles here. Okay, this is not going to be none. But with those right triangles, for it to be hypotenuse leg, we would need the hypotenuse marked and the leg marked. So if I look just to this right triangle on the top, I would need the hypotenuse here, AB, to have a dash mark on it. So this is not going to be HL this time because there's no markings on the hypotenuse or the leg. So now we're down to angle, side, angle, or angle, angle, side. Now, something else you might notice is there's this line of reflection down the middle. That's going to be our reflexive property. So that's an assumption that you can make. So you can assume reflexive property. So now, again, a process or a strategy I use is I cover up one of the 2 triangles, okay? If I cover up one of the 2 triangles, I'm now just isolated in one picture. This angle corresponds to the one and the other. This side is shared between both in this angle. So these are the markings for angle, side, angle. So the best answer there is going to be ASA. Okay. Scooching over to 8 and 10. Oh no, these 2 pictures are similar to each other, okay? Where there's 2 triangles that are kind of fused together along a side. So just like I have that reflexive property, I'm also going to have it here and here. So these 3 pictures, since the diagrams, so here it's a reflection over, this is just a different reflection. The points are in a little bit different places, okay? And here, these are just oriented a little funny too. But these are all reflections, meaning you have your reflexive property. So that I'm just going to automatically go in and mark up no matter what I do to get us started. Perpendiculars. AB is perpendicular to BC. AB, BC, right angle. The next bit of information is actually another angle. So if we have one right angle there, we're going to have another one down here. AD is perpendicular to DC. So both of those pieces gave us a set of angles, not 2 sets of angles, just 2 individuals. And the last case, AB is congruent to AD. So now we have 2 sets of sides and a set of right angles. So I'm going to eliminate angle, angle, side, because I don't have anything but one set of angles, an angle, side, angle. I do have 2 sides marked, but I don't have a third side marked. So how I think through this, I don't have all 3 sides marked in here to all 3 sides here. So it's not going to be side, side, side. I'm keeping HL because we do have right angles. So how do I like to explain this? Again, I'm going to cover up one of the 2 triangles. I'm going to cover up the top one. So I'm just isolating this triangle ADC. Okay. Do I have the hypotenuse of that triangle marked congruent to the hypotenuse of the other one up here? I do. Do I have a leg marked? This is a leg congruent to that leg. Do I have a right angle? Yes. So this is the case for angle side side. Okay. This is an angle marking, a side marking, and a side marking. That says ass. But now we rename that. Right angle, leg, hypotenuse makes it HL. The reason it's not side angle side is side angle side looks like this. When you have the two sides marked, you would need the angle between them. So the best case here was HL. Just because it had a right angle doesn't automatically always make it HL though. So these were different for that reason. Number 10. AB is parallel to DC. This is a symbol we haven't seen yet in our proofs. But when you have parallel lines, you do create alternate interior angles. So those parallel lines gave us alternate interior angles. Okay. And they also tell us that AB is congruent to CD. So again, I'm going to take a Post-it note here. Maybe. I'm going to cover up one of those two triangles. All right. So I'm just isolating one triangle at a time, and I'm going to look at the markings. I have a side marking, an angle marking, and a side marking. So the method of congruence here for number 10 was side angle side. All right. That a side angle side in one triangle is congruent to a side angle side in the other. So again, that's where it's helpful to just stop at one picture at a time. Couldn't have been HL. We didn't have two angles in either triangle. There was only one angle marking. Nothing was at the other angles. Okay. So I know that was a lengthy explanation of these methods. If you want to try numbers 9 and 6, you can go back to those. But your classwork 306B is now what I'd like you to try on your own. These first 3 questions are throwback questions. With number 3, I highly suggest you drawing a triangle ABC that's congruent to another triangle DEF. Mark up the pictures with the rest of this given information to solve for your value of X. So here are 3 short answer questions based on the parts of a triangle. This is kind of going back to your first packet for this unit 3. Number 4, you have triangles marked for you. I'd like you to decide what the method of congruence is, see how you understood the lesson for today. And to be honest, I want you to skip the back, okay? So those of you listening to this whole video to the end, for now, we're gonna come back to 5, 6, and 7 down here at the end. We're gonna skip those 3 for today. We're gonna work on those next class when we go to do notes 3.07. Thank you and have a great day. Again, we want you to try exercises 1 through 4 here on your own on classwork 306B and submit that to us.